This tutorial is the final review for Chem 119 Exam 3. First of all, you're going to need to know what chirality is, the DNL classification, and what enantiomers are. Remember that a chiral compound is a carbon with 4 different things that are coming off of it. That's super important. Here's the difference. CH2OH. So that looks like hydrogen, hydrogen, OH with another carbon up here. Notice that the hydrogens, you have 2 of the same thing. A chiral compound is something that has 4 different things. So here's our carbon. We have a hydrogen here, CH2OH here, OH, and then all of this up here. You have 4 different things coming off of that same carbon. That's what you want to look for. Now when it comes to DNL classification, if you put the most electronegative part on the top, which here we have a carbon double bonded to an oxygen and then a hydrogen. Because of this double bond, it's the most electronegative, so that's going to be pointed up. So you make sure the CHO is pointed up. You go down and you look at the last chiral center. So the last chiral carbon right here. Remember, this part down here is not chiral. If that OH group is on the left, it's the L. If it's on the right, it's a D. That's all you have to look for. Make sure CHO is on the top, go all the way down. The last chiral carbon, if it's on the left, over here, it's an L. If it's on the right, it's a D. Enantiomers are basically what these are called. If you put a mirror image here, if you put a mirror in there, you can see that these are reverse of each other. That's what enantiomers are. They're two chiral compounds that are mirror images of one another. Alright, so know the different classifications and how generically to name the carbohydrates. So we have aldo and keto. Aldo is coming from the term aldehyde, where keto is coming from ketone. Now if we look how that changes in the formula, notice that with an aldo, the double bond is on top, because an aldehyde is a terminal functional group. So therefore it's at the top. Ketone has carbons on either side, so therefore it's going to be in the middle somewhere. So keto, your double bond is going to be in the middle. Aldo, your double bond of oxygen, is going to be on top. Then pentose, hexose, tetrose, so on and so forth, have to do with the number of carbons. So we have 1, 2, 3, 4, 5, 6. So it's hexose. Because it's on the top, it's aldohexose. 1, 2, 3, 4, 5, which is making it pentose. Double bonded oxygen's in the middle, so it's ketopentose. Know the different monosaccharides. There are 3 things. There's 3 monosaccharides. You should be able to spot them. Galactose and glucose are very, very similar to each other. If you do a direct comparison, the only difference is going to be on this 4th carbon. That alpha beta here, the first carbon, either one of them could be alpha or beta. Either one of them can go up or down. It's the 4th carbon that's going to be consistently different. So if it's down, it's glucose. If it's up, it's galactose. How do you know where to start counting? Here's our oxygen. We're going to count from the oxygen. 1, 2, 3, 4. The 4th one is pointing down. Here's the oxygen. 1, 2, 3, 4. The 4th one is up. That's galactose. Now fructose is very obvious when you look at it, because unlike glucose and galactose, fructose started off as a ketose rather than an aldo. So therefore, it turns into a pentagon rather than a hexagon. We have a carbon sticking out at the bottom here and a carbon sticking at the top up there. Whereas we only have one carbon coming out there. And that's because the oxygen was in the middle of the chain rather than at the end. The disaccharides, there's 3 to remember: sucrose, lactose, and maltose. You just have to flat out memorize these. Glucose and fructose combine to make sucrose. Some things to look for: the bonds going up and down here. Also, you have a pentagon. The other 2 don't have a pentagon in it. Only the sucrose does. Once again, that's because of fructose being a keto. Lactose is here. Notice this is galactose and glucose combining. So look at the 4th carbon. Glucose, the OH is down. Galactose, the OH is up. Those 2 combine to make the lactose. So this was originally pointing down, and it bonded with that OH group there, with that carbon there. And then here with maltose, glucose and glucose, once again, OH is down, OH is down. So when you're looking at which disaccharide it is, look at what makes it up. So sucrose, we have glucose with a hexagon with the OH down, and a fructose with a pentagon. Lactose, we have galactose and glucose coming together, OH up, OH down. And then with maltose, we have glucose and glucose coming together. Both of those 4th OHs are down. Finally, there's the polysaccharides. There's actually 4 polysaccharides. The amylose, notice we have the alpha. If it's going in a V shape, you know you have an alpha. These are all, the OH on the 4th one is all going down, so that means these are all glucose. So amylose is a long chain of those glucose. Amylopectin and glycogen are very, very, very similar. Notice the OH is still going down on that 4th carbon. And you still have that V shape. Except amylopectin and glycogen have branches. So there could be another one coming up here and going down. So glycogen branches more than amylopectin. But other than that, they're very, very similar. Cellulose, look at the difference here. Once again, we still have that 4th OH going down. But instead of that V shape, we now have a line. We have a beta 1,4 glycosidic bond. And that's how you tell the difference between them. And that's the final review of exam 3.